You click an icon, a program just pops up. You talk on your keyboard, and letters appear on the screen. It feels totally seamless, almost like magic, right? But behind that screen, there's this incredibly complex, bustling world of hardware components all trying to work together. So how does your computer take all that potential chaos and turn it into the smooth performance you expect? Well, the answer lies in its operating system, which, as we're about to see, acts a lot like a powerful government, bringing order to a nation of hardware. So, let's pull back the curtain and see how it really runs the show.
So here's our game plan. First, we're going to meet the citizens and resources of our hardware nation. Then, we'll introduce the OS government that steps in to bring order. After that, we'll dive into the laws of the land it uses to enforce all the rules, check out its advanced operations for managing the nation's wealth, and finally, we'll see how these governments are evolving into some really complex forms.
All right, so first up, let's talk about the nation itself. You can think of every single computer as a country built from physical parts. It's a land that's rich with these incredibly powerful but kinda unruly resources, and they all need a strong leader to actually become productive.
So think of the CPU as the brilliant, lightning-fast brain of the operation. The main memory, or RAM, that's its short-term workspace, where it keeps what it's working on right now. And then you've got all your I/O devices, the keyboard, the mouse, the printer. Those are like the ports and communication hubs talking to the outside world. And everything is connected by a common bus, which is kind of like a national highway system. The problem? Well, they all work at wildly different speeds and they all speak different languages. It's a recipe for chaos, right? This creates a massive coordination problem. I mean, how in the world do you get a super-fast CPU to work with a much slower keyboard without the whole system just grinding to a halt? That's the big question here. Without some kind of system of governance, this powerful hardware nation would just be useless chaos. And that is where our government steps in. The operating system, or OS, is the program that provides the structure, the rules, and the control needed to manage this hardware nation and turn it into a productive society for you and all of your applications.
So what is an OS really? At its heart, it's that essential go-between. It's a layer of software that basically shields your applications from all the messy, complicated details of the hardware underneath. It creates a stable, predictable environment so that your programs can just get their jobs done.
And this OS government really has two main jobs. On one hand, it's a resource allocator. It acts like a national treasury, deciding which programs get precious CPU time and which get a slice of memory. And on the other hand, it's a control program. This is the police force, basically, preventing errors and stopping programs from messing with each other or trying to hog all the resources. There's this quote that just absolutely nails it. The OS itself doesn't browse the web for you. It doesn't edit your photos. Its entire purpose is to create a well-managed environment where your browser and your photo editor can do their jobs effectively. At the end of the day, it's the ultimate facilitator. So, okay, we've established the OS is a government, but how does it actually, govern? How does it enforce its rules? Well, it relies on a whole set of established laws and procedures to manage everything. First up, let's talk about interrupts. Imagine the CPU is a president who's busy working on some really complex policy document. It would be incredibly inefficient for the president to stop every single second and yell down to the mailroom, "Hey, is there an email yet? How about now?" right? Instead, the mailroom only sends an urgent message, an interrupt, when a letter actually arrives. This lets the president stay focused on the important work. And that's exactly what the interrupt cycle is. The CPU basically delegates a task, like getting input from the keyboard, and then it moves on to other things. Once the keyboard has something to report, it sends that interrupt signal. The CPU then pauses what it's doing for just a split second, handles the new information, and then seamlessly goes right back to what it was doing before. This whole process is the key to managing a bunch of different devices all working at different speeds. But wait, how does the OS government talk to all these different devices? I mean, they're all made by different companies. Well, it uses device drivers. Think of these as highly specialized government agencies. The OS doesn't need to know the specific technical language of every single printer model out there. Nope. It just sends a standard print command to the department of the printer, that's the driver, which then translates it into the precise signals that that specific piece of hardware understands. And finally, we have system calls.
You can just think of these as the official paperwork. An application can't just barge into a government building and start grabbing sensitive files. No way. Instead, it has to fill out a form, a system call, to formally request access from the OS. This little bit of bureaucracy is absolutely crucial for making sure that all the important resources are used in a controlled, secure, and orderly way. Okay, so we've got the laws and the bureaucracy. Now let's get into some of the more advanced operations of our OS government, like how it manages the nation's wealth. And in a computer, the real wealth is its data. This requires a really sophisticated system for storage and retrieval, a lot like a national treasury.
See, in a computer, not all data storage is created equal. The OS manages what we call a hierarchy, kind of like a pyramid. As you go up the pyramid, the storage gets way faster, but also more expensive for every little bit of data. And as you go down, it gets slower, but a whole lot cheaper. The real genius is in how the OS manages this trade-off.
So let's break this down. At the very top, you have registers and cache. Think of this like the cache in your wallet. It's super fast to get to, but you can't hold very much of it. And notice that it's volatile, which just means that when you turn the power off, that data vanishes, just like spent cash. Now, way down at the bottom, you have magnetic disks. These are like the big bank vault. They're non-volatile, so they hold huge amounts of data permanently, but they're pretty slow to access. The OS's job is to be this brilliant financial manager, using a technique called caching to intelligently move the information you need right now up into those faster, more expensive levels.
All right, so just like real-world governments, the ones inside our computers are always evolving. The model of a single ruler or a single processor isn't the only way to do things anymore. Let's take a look at some of the more advanced forms of digital governance.
So welcome to the world of multiprocessor systems. Instead of one CPU doing all the work, you have several working together. This isn't a monarchy anymore. It's more like a council of leaders, where multiple executives can tackle the nation's problems all at the same time.
And the advantages of having this council are, well, they're huge. With more leaders working in parallel, you get increased throughput, which is just a fancy way of saying more work gets done in less time. You also get a better economy of scale. And maybe most importantly, reliability goes way up. If one processor fails, the others can just pick up the slack. This is called graceful degradation. The government might be a little weaker, but it doesn't totally collapse.
And this council can be organized in two main ways. In symmetric multiprocessing, or SMP, every leader is a generalist. They're all equal, and any one of them can handle any task that comes along. In asymmetric multiprocessing, it's more like a cabinet with specialized ministers. You might have one processor that handles all the finances, another that handles defense. You get the idea. Each one has a specific job.
Okay, so let's take this one massive step further with clustered systems. Now imagine, it's not just a council of leaders within one nation, but an entire alliance of completely separate nations. Each nation is its own independent computer, but they've all agreed to work together, often sharing a critical resource like a massive storage network. This kind of alliance provides incredible levels of power and ensures that even if one entire nation goes down, the alliance keeps right on functioning. And this all brings us to one big final thought. You know, the simple computer nations of the past are quickly becoming these vast, interconnected empires. We're talking about our phones, our cars, our smart homes, all being powered by AI. So the real question becomes, what new forms of digital government, what new kinds of operating systems are we going to need to run this incredible, complex future?